Welcome back, everybody, to Calculus AB. Today's topic rates of change in applied context other than motion. This would be topic 4.3. The learning objective is interpret rates of change in applied context. So, example one from the 2010 AP Calculus exam, ABBC1. So, there's no snow on Janet's driveway when snow begins to fall at midnight. It says from midnight to 9 a.m. Now snow accumulates, right? It's an accumulating on the driveway at rates modeled by f of t equals 7 times t raised to the e raised to the cosine of t cubic feet per hour, right? Units. Where t is measured in hours since midnight. So Jane starts removing snow at 6 a.m. and the rate of g of t in cubic feet per hour at which Janet removes snow from the driveway at time t hours after midnight is modeled by g of t. So if you remember, so we have zero, that means she's not removing anything between the first 6 hours, right? And then between the first hour, she's removing 125 cubic feet per hour. And then from the seventh to the ninth hour, she's removing about 108 cubic feet per hour. Now, keep this in mind that at the same time you have snow falling. All right. So that's very important. So we're still adding snow to this. And at the same time, we're taking away snow. Right. So the best way to do this is that she pretty much takes away more snow than it's being added. Right. So let's see how we can find the rate of change. So find the rate of change of the volume of snow on the driveway. So right? We have something that's adding and something that's taken away, right? So rate of change. So let's use capital R of t. So the first function is adding, right? So that's going to be f of t, and then the second function is she's taking away. So I'm going to be subtracting. So that's minus g of t. Right? So this is again the input, and then the other one will be the output function. If you want to think about it that way. So after this, it says we want to find the volume of the snow, right? So what is the volume of the snow at 8 a.m.? So that would be at t equals 8. Remember, midnight is 0. So that's why we're doing this. So let's look for the rate of change. So r of 8, all right, equals f of 8 minus g of 8. And then this just becomes a substitution problem pretty much. So all you guys have to do is find f of 8. Again, use the calculator. Please use the calculator. All right. If you do that, you find that f of 8 is equal to, we're going to get 48.417. And then g of 8 is given by this function, right? 8 is between 7 and 9. So that means we're taking away 108 cubic feet per hour. So we do the subtraction right there, and that's going to be negative 59.583. So we can say that she's removing negative 59.583 cubic feet per hour. All right, let's look at example two. For this one is just find the rate of change. It wasn't asking for an explanation, so that's why I only just did the units. All right. So for the next question, it says a penguin population on an island is modeled by a differentiable function p of time t, where p of t represents the number of penguins and t is measured in years between 0 to 40 years. There are 100,000 penguins on the island at t equals 0. The birth rate for the penguins on the island is modeled by b of t equals 1,000 times e raised to the 0.06 t penguins per year. And the death rate is modeled on the island by d of t equals 250 times e raised to the zero point 0.1 t penguins per year. What is the rate of change of the penguin population at t equals 0? All right. So at t equals 0, pretty much we know that we had initially, right? So again, we know initially we had, I would say, 1,000, right? So let's see what happens at t equals 0, right? So at t equals 0. So again, we're looking to see how is the population changing. So let's use R of t, right, to figure out the big rate. And then that's going to be equal to the born, right? The birth rate, which is B of t, and then how they're dying, which would be minus D of t. All right. You can do this in the calculator if you want, but technically, right, if we're doing R of 0 here, if we substitute 0, this just becomes 1. So that gives us 1,000 minus. If you substitute 0 here, this just becomes 1 again, so that's 250. So that's gonna be equal to 750. So 750 penguins per year. All right. Never forget the units, especially on those rate of change